Okay, so hello, my name is Thorsteins, and don't worry, you will not need to repeat that, but I am a security data scientist from Panacea, and as you said, today I'm here to talk to you about data science buzzwords and how to see through them. So to start off, I'm just going to bring up a few statements taken off the websites of real companies. And as I bring these up, I just want you to think critically about what these statements actually mean. So first one, Company 1 is a leading artificial intelligence vendor that offers targeted machine learning applications which optimize the bridge between digital and offline channels. Pretty self-explanatory.
You want guesses?
I mean, feel free to, if you have some guesses, feel free to shout out, but it's not necessary. I'm not putting anyone on the spot here.
Probably anti-fraud, mobile and web.
I was thinking they actually got a bunch of words off the web and had no idea what it meant, but it sounded good.
Yeah, that was kind of more what I was leaning towards, but Company 2 is the only provider of global, real-time, unlimited information and insights driven by leading artificial intelligence. Again, very obvious what this company does. And then my favorite one, learn how automated machine learning supercharges your analytics efforts. I don't know exactly what they mean by supercharges, but I quite like the way they phrase this. So, I don't know about you guys, but I mean, I do data science for a living, and I still don't really have any idea about what they mean by these statements. And I mean, that being said, this doesn't tell us anything about how good these companies are. They very well may have a fantastic product under the hood. But the problem is that they're just not revealing anything about what they do, how they do it, or how well they do whatever they do. And this kind of stems from the fact that buzzwords are created to impress, not necessarily to give any information away. So they often create this illusion that by sounding more complex, things are necessarily better. But obviously that is not always the case at all. And I mean, I think we've probably all been guilty of falling for this at some point. I can definitely say yesterday I was walking around InfoSec and I saw a lot of headings that it was very ambiguous what the companies did, but I still found myself very compelled to go towards the booths that had some kind of short, impressive sounding phrasing, sleek font. And I mean, that's completely fine. As I say, sometimes the companies actually are doing something very valid, but it's just important to think critically about what they're doing and actually asking about anything that isn't clear. Because if someone can't explain what they do without relying on buzzwords, that's a huge warning sign. So I'm going to focus on three, let's say, celebrities from the data science buzzword world. And the first one up is data-driven. Now, I think a lot of companies use this, and what it essentially means is just that they use data to do whatever they do. And to me, at this point, this actually seems a little bit redundant when we're talking about security applications, because I think it's difficult to find applications that don't use any data. So it's more kind of, this phrase is used more to impress rather than actually tell you anything. So the key things to ask when someone says they've got a data-driven application is, what data are they using and how are they using that data? Because that's what's going to differentiate between a good application and one that isn't as good. I think the most commonly used data science buzzwords these days have to be artificial intelligence and machine learning. And it's going to differ quite a lot depending on who you ask, what definitions you're going to get. Even if you ask the experts, you get slightly differing opinions. So I've included this slide for context, just to explain that the language that I'm using for the purpose of this presentation is the language that's kind of most commonly agreed upon in the industry. So that is that machine learning is a subset of artificial intelligence. And so as I go on, I'm actually just going to focus on artificial intelligence specifically, but just keep in mind that anything I say about AI, you can also use the same techniques whenever someone says something about machine learning. So that brings us to buzzword number 2, which is AI-powered. And this can mean a whole host of things. Best case scenario is that they've got some high quality data or high quality models that they're using where appropriate to make the application better. However, in a huge number of cases, that's not the case at all. Research recently actually showed that 40% of EU startups that are classified as being in the AI space actually have nothing to do with AI or don't use it in any measurable way anyway. So you also have cases when there is some machine learning element, but it's mostly been included for marketing purposes. So it's not like it's actually making the application any better, but they're sort of trying to tack onto this bus that machine learning is cool and that they're doing something intelligent. So they've included it just to impress rather than actually return better results. And then there's the weirdest case when they actually don't have anything to do with AI. And so I'd say the most important thing to remember when anyone says anything about using AI is just not to get too impressed, but remember that AI is a tool. And AI, it's a tool that's very powerful when used correctly, but it is also only a tool. It's not a magic fix-all solution like it's often perceived to be. It's often marketed like you can just throw any data at any problem and magically you'll get the correct answer at the other side. And that's obviously not the case. There's a lot of prerequisites for it to even make sense to use AI. So first of all, you have to have a well-defined problem. So if anyone says they're doing AI, but it doesn't sound like the problem they're trying to solve is well-defined, then you can immediately outrule that they're actually doing anything to do with AI. And to use a very, a very popular phrase in the data science community, rubbish in, rubbish out, which just means that the quality of the model you have is only ever going to reflect the quality of the data you use to train your model on. So if you're using data that's not extensive enough, that has biases you're not accounting for properly, then the model is going to be hugely flawed. And this is something that needs to be taken into account. The last one is advanced analytics. And as we saw on the graph before, this is the one that's widest in scope. And what it essentially means is just that it's more advanced than basic analytics. And I mean, this contains things such as artificial intelligence, machine learning, but it also contains things like particularly well-constructed graphs or a very advanced visualization. So the thing you need to ask when someone says they're doing advanced analytics is, what do you mean? What sort of advanced analytics? To round the talk up, I've prepared a buzzword cheat sheet, so you have something to take away from this talk, so you can be armed next time you're presented with a very fancy-sounding statement, sounds very intelligent, like they're doing something very cool, but you also don't really know what they're doing. And to help me demonstrate the use of this cheat sheet, I'm going to rely on one of the statements from the first slide. So there's a lot of things about this statement, as we loosely covered earlier, that are not clear at all. So the first thing I would ask if someone said this to me, which is, what do you mean? And get them to break it down into simpler terms, because if they know what they're doing, they should be able to phrase it in a way that's easier to understand. And so if they say anything like, trust me, it's AI, then just stay clear. That's not someone you want to get involved with. Then dive in a bit deeper. How specifically do you use, I guess in this case, machine learning, but you can use this for any of the other buzzwords. And this is because, as I said earlier, there's a set of pre-requirements that need to be met for it even to make sense to use machine learning. So you need to understand what problem are they trying to solve, and have they taken into consideration the limitations of these approaches? Why did you choose to use this technique, so machine learning here? And this is getting towards, have they actually considered the limitations, or have they sort of just used it for the sake of using it because everyone else is doing it and they wanted to get on that bus as well? How was the model trained? And this is quite key because as I said earlier, the model is never going to be better than the quality of the data that was used to train the model on. So if there are any biases in the data they haven't accounted for, if they've trained it without taking into consideration some security flaws. So, for example, neural networks often store information that they train on. So for specific use cases, you actually wouldn't want to use this at all. So you need to know how they trained the model and whether they trained it correctly for the use case they have. Can I validate the decisions being made? Now, this one is not actually always going to be possible to validate it. And for example, with neural networks, it is always going to be a bit of a black box. You don't have full visibility on what's going on. But that also means that will not be an applicable approach for, say, making important security decisions. Because for those, you need to have visibility on what's happening. So when you have a question like that you're trying to solve with this, you need to make sure that you can validate what's being done. And then lastly, a bit of a technical one. How do you minimize false positives or false negatives? So this one is going to depend a little bit on the question, but for some cases, it's going to be very costly to falsely predict a positive or negative. So say, for example, if you were working in healthcare and you were predicting whether someone had a specific disease, it would be quite bad to falsely say you don't have it. Whereas if you falsely say that a few more people have it than actually do, the result of that is going to be not as bad. So you need to know whether they've taken into consideration how to minimize the cost, I guess. So if you take one thing away from this presentation, it's that you shouldn't worry about asking thick questions, even if you feel like they sound naive. Don't find yourself getting so impressed and so intimidated by these statements that you just don't question at all, and you just say, oh, these people sound like they definitely know what they're doing. They've used all the cool words. I'm not going to give away that I don't know what these things mean. So ask about anything that's unclear. And that kind of rounds it up. Does anyone have any questions?
I think that's wonderful. By the way, trust me, that's a term we use in Texas. It means you're about to get hosed for a lot of money, and we're not going to do anything that we claimed. Any questions?
This was awesome. Thank you so much. How do you get past, so when someone tells you the answer to one of those questions is, oh, I'm going to have to get my data scientist in here to explain that to you.
So that's probably going to be the case a lot of the times. And in a lot of cases, they won't even want to give you the answers. So what you need to take into account is how important is it to you to know these answers. So I think, definitely try to press for the answers, because someone in the organization should have the answers. Obviously if you're like, oh, tell me the exact model you're using, they're not going to want to tell you that. But
follow on to that.
Yeah.
Do you consider the architecture of a neural network proprietary? Sorry, just for the record. So as a follow-on to that, do you consider the number of layers and the model of a neural network to be proprietary?
Personally, no. Some cases people would, because a lot of the times the models underneath the hood actually aren't that complicated at all. So companies don't want to reveal how simple their answer is, just because it would be so easy for other people to pick it up. But, it shouldn't be the case though.
Yeah, usually when someone makes a comment like, I need to talk to my data architect, and they've been selling the product for a while, it means that they haven't got a clue, and you should run the other direction.
That's a good point.
Next question.
So you're a data scientist, right? So do you think that someone in the future, AI will take over the world?
Sorry, that?
Somewhere in the future, AI will take over the world, will dominate the world.
So this is a hot topic. I'll probably got to be careful about how I answer this. Yes. I mean, at some point in the future, so I'm a mathematician, so I when you say at some point, I'm kind of thinking indefinite time. So yes, at some point they're probably going to. In our lifetime, I actually don't think so, just because I think we're quite far from getting anything that's actually intelligent. So we made huge progresses in making machine learning algorithms that solve specific tasks very, very well. So, for example, image classification, that's one that we made a huge progress on. But those algorithms, they wouldn't automatically decide to learn French or pick up a political opinion, which is what's required for actual intelligence. And I think that machines are going to need a level of intelligence to actually take over the world. So yeah, I don't think so.
You might have wanted just to stop there. We don't think there'll be intelligence to take over politics in the world. I mean, I speak French and I've got political opinions, but I don't want to take over the world. Other questions?
What do you do if assuming you don't know anything about sort of the data science side of stuff, but you still want to understand whether it's snake oil? If they come back to you and say, try and bamboozle you with like, it's a 7-layer GAN, we're trained on a WTF data set or something, how do you cut through that to actually understanding what they're doing?
I'd say just use the cheat sheet, ask them very simple questions and try to get beyond, because it's not really going to matter what exact model they use, but what's going to matter is whether they've taken into consideration the limitations of their approach and whether they actually have, whether you think they have access to data that's of significant quality, whether just how well they've thought about the problem and how well they can explain why they're doing what they're doing and why it works.
So that goes with your corollary. If they ever say, well, I don't think you would understand.
Yeah, then that's a big warning sign.
Just a comment. It's not much different when they say blockchain powered.
Yeah, I mean, that should have been on there as well, but I had to restrict the scope.
Okay. Any other questions? No? Go once, twice? Thank you. Wonderful presentation.